Hello, my friends. I'm Clover, and this is Gas. Today we're solving a puzzle called Fog on the Dominoes by Philip Newman. So this is a killer domino fog Sudoku. So first of all, even though the grid looks a little bit funky, I'll explain what's going on here. So we're going to have normal Sudoku rules. So we're placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. There is also fog covering the grid initially. When we place correct digits adjacent to a fog cell or on a fog cell, that cell and the surrounding ones will clear of fog and we'll be able to see what clues appear under them. So it's kind of a way to control the order that we're allowed to solve the puzzle in without giving away steps that are meant to come at the very end. So then there are also some dominoes, which are just 2-cell cages in the grid. So all of the cages in this are 2 cells. And that's actually going to be really important here because with this fog, if we didn't know for sure that these cages were only 2 cells, we wouldn't necessarily know which cells this 15 covered. It could go just here and here, or it could go like all the way down here, and we wouldn't know. But because in this puzzle it's killer dominoes, not just standard killer, we do know in this case that this 15 cage, for instance, is literally just these 2 cells. And there's a clue in some of the killer cages, and it tells us it tells us the sum of the digits in that cage. And of course, because it's dominoes, as well as because of standard killer Sudoku rules, we can't repeat digits in cages. So a 3 domino has to always be 1 and 2. And the 7 is fully in the row with the 1 and the 2, so we can't use a 1 or a 2 as part of the 7, so that must be 3 plus 4. And then a 4 and 2 cells is always going to be 1 and 3. Now we already have a 3 in the region as part of the 3-4, so that's going to be our 1, that will be our 3. And now the 3 is looking at that, and we have a 1 in this region, so that's a 2 and a 1. Now we see we've uncovered a 17 domino, so that has to be 8 plus 9. And then 15 is going to have to be either 6 and 9, which will go like that, because this will share a region with the 8-9 pair, or 7 and 8, and we can't distinguish those yet. A 16 domino is going to be 7 and 9. And then a 14 domino has to be either 5 and 9 or 6 and 8. But because there is already a 9 in the region from the 16 domino, this has to be 6 plus 8. And then we can pencil in the remainder of this region. We still need the digits 1, 2, 4, and 5. 1 and 4 can't go in these 2 cells, so they go there. And then this is going to be a 2-5 pair. Now, the next step that I took here, and this took me a minute to actually see, is to ask myself where 9 goes in the top left region. There's a 9 in this row already, so 9 can't go in those cells, and then there's a 9 in this column already as part of the 7-9 pair, so 9 can't go in those cells, so 9 must go there. So that's a 9, and that makes this a 6. That has now uncovered this 5 domino. There's a 3 in the row with it already, so we can't do 2 plus 3, we must be doing 1 plus 4. This is now an 8 domino, it can't be 4 plus 4, that would duplicate, and there are several problems with that, so it must be 1 plus 7, placing the 4 here, and the 7 also resolves that 7, 9. This 6 domino can't have a 1 in it, so it must be 2 plus 4, and those are arranged that way because we already have a 4 right here. This 13 domino, there are 3 ways to do that normally. 4 and 9, which is impossible here because of the 9 in the row. 5 and 8, which is still on the table, and 6 and 7, which is also impossible because of the 7 in the row. So this must be a 5-8 pair, which makes this a 2 and makes this a 5. Now, the remaining digits in this row are going to be 3, 4, and 6, I believe. That can't be a 4. Okay. Here we need to place a 2 and 3 in this region. They can't go in these 2 cells because of the 2 and 3 right there, so there'll be a pair there, and then these now have to be 5 and 7, making these cells 6, 8, and 9, and then from there I looked at the 11 cage, because 11 has to have a high digit in it, but I've already used 3 of my possible high digits, so my only remaining high digit is 7, so the 11 must be 4 plus 7, like that. If I look at this row, I still need 2, 3, 5, and 8. 8 can't go in here because of the 6, 8, 9 triple, so 8 will go right there, which resolves the 6, 8 domino. This triple is now 5, 6, 7. We can place the 5 because there's already a 6 and 7 in column 2, and then that's going to be a 6, 7 pair. These are going to be 1, 2, and 3. 6 can't be in this 12 domino. 4 also can't because 4 would be paired with an 8. And there's already an 8 placed in this row, so this must be 3 and 9, which resolves like this. We can eliminate 3 there, and we can eliminate 9 here. And then our last 2 digits here will be 5 and 7 in that order, because the 7 takes care of that, and that resolves this as well. Now these three cells in the remainder of region 5 are going to be 3, 8, and 9. I'll resolve this real quick too because we have the 5 in the column. Now how do we make 10? 3 and 7 is out because there's a 7 already. 9 and 1 is out because there's a 1 already, so there must be an 8 here with a 2. And then there's a 3 there, a 2 there, and we can do some classic Sudoku to tidy up a little bit in the top of the grid. Now down here, we still need 5 and 9 to finish this column, and we can't put a 9 in a 2-cell 9 cage, so that's my 5, and it goes next to a 4. Now these digits, these are going to be 3, 7, 8, and 9. Well, can't use a 9 because there's 9 in the region already. And these are going to be 1, 3, 6, and 8, and 1, 3, 6, 8. Okay, perfect. So now, if we look at these 10 cages, these are pretty restricted. It takes a moment to see it, but here's what's going on. 1 would go with a 9, which is okay. 3 would go with a 7, which breaks because there's a 7 in the column, so that can't be 3. And it also can't be 6 for the same reason. 6 would have to go with a 4, and 4 has been used in the column. And 8 would have to go with 2, and 2's already there in the row. So the only possibility remaining is 1. So that's a 1 with a 9, which resolves this 6, 8, 9 triple. This guy would have to be 3 plus 7, again, no. 6 plus 4, again, no, and so it must be 8 plus 2, and we can remove 8 from these cells, revealing that this has to be a 6, and we get the entire rest of the middle of the grid, except for these 2 digits, which we will resolve shortly. Those resolve via classic Sudoku. Here in this row, we're going to need a 2 and a 6, which don't quite resolve yet. And this column, we need 5, 6, 7, and 3, so that has to be a 7. It's a naked 7. I need a 3 and a 5 here. In these 3 cells, I need 1, 2, and 4, which resolve by Sudoku, and in these, I need 6, 8, and 9. I have an 8, 9 in that row. That's my 6. That's going to be my 8. That's going to be my 9. Now, to finish off this row, I need 3, 4, 5, and 7. The only position for a 4 is there. That has to be my 5. And those are all resolved. And here I'm going to need 6 and 7 to finish this row. And that should take care of, of the remainder of the grid. And that is how you solve Philip Newman's lovely Fog on the Dominoes. Hope you enjoyed that one. If you want to check it out yourself, the link to do so is in the link immediately below this video. And I will see you again 3 days from now.